Good evening, good evening. So please mute yourself and we can just go for next postulates. So in last classes, what we have done, we have just go for the two very basic postulates. The postulates, one will tell all about the states, and that states can be treated as a probability density, which will tell you what will be probability to find the particle between x to x plus dx. And we have also find what are the basic formulation that mod psi square, if psi is state, then mod psi square is probability density. And the second postulates is very important postulates, and that tells you about the physical measurement of a state. And if we have any physical observable quantity, there is associated operator, and that operator is basically mathematically attached to that physical quantity, and the eigenvalue of that operator is the physical measurement, and eigenvector known as the eigenstate, which will make a complete basis. And we have done all this thing. So in one liner, if you want to say about the postulates 1, this will be all about psi, and this psi can be written as some basis of another psi. And we have mod psi square as probability density. And second postulates will tell you the operator A phi n is equal to an phi n, where an is the physical measurable quantity, an is the measurement, which is actually eigenvalue, and phi n is the eigenstate. So we have phi n summation over n is equal to identity, because this phi n will make complete basis. What is meaning of that? Meaning of that, we can represent this psi in a basis of phi n. How we can represent this psi? We can represent this psi as equivalent to I psi. So I can write this whole term as summation over phi n psi. So what we have done, if A is going to measured on any state psi, if A is going to measured on any state psi, which means psi can be represented in a eigen basis, in a basis of eigen state. So you can write any state psi in a basis of eigen state, then only you can measure it. So in the last class, I have also discussed one problem, or we can again repeat this problem. Suppose I have operator A naught 0 0 to A naught, and if this operator is measured on, let's say, any state psi, and this state is, let's say, 3 5, I can represent the state as 3 5, then what will be measurement? Measurement is nothing but the eigenvalue, and that will be A naught and 2A naught. And we have also eigenvector associated to these eigenvalue. Those are well known as eigenstate. So I can say that A naught is eigenvalue associated to eigenstate phi 1, that is 1 0, and 2A naught is associated to eigenstate phi 2, that is 0 1. You can easily find the eigenvalue and the eigenstate. What is meaning of that? Meaning of that, I can represent this psi, I can write this psi as a 310 plus 501. I can write psi like that, but it is very trivial, so I am writing it directly. Just by visualizing this thing, I can write it directly. Otherwise, what I have to do, I have to use this completeness relation. I have to use this completeness relation. Once I will use this completeness relation, what will happen? This psi is actually 3, 5, can be represented as linear combination of eigenstate. So what will happen? 3, 5 can be written as 3, 1, 0 plus 5, 0, 1, and this can be written as psi as 3, 5, 1 plus 5, 5, 2. So what is meaning of that? Meaning of that, this psi is only representation, and this psi is representation of linear combination of eigenstate phi 1 and phi 2. And what will be the eigenvalue associated with phi 1 is 2a naught, we can easily calculate. And what will be the eigenvalue associated to phi 2? Sorry, with phi 1 is a naught, and what will be eigenvalue associated to phi 2 is 2a naught. So what will happen? This is a something like you are coining a toss. So you have one coin, and you can say that after the tossing it, you can get either head or tail. This is the wonderful thing. So similarly, when you can analytically, you can see that this state or this coin have two faces. One face is identified as phi 1, another face is identified as phi 2. And I can tell you, suppose we can play a game, and what I will tell you that if you will get phi 1, means I will give you 100 rupees, and if you will get phi 2, that means you will give me 100 rupees. Means the value associated with this phi 1 is 100 rupees, and here the value associated with phi 2 is 200 rupees with respect to me, if I the thing. So similarly, in quantum mechanics, I can say the value associated with phi 1 is a naught, and the value associated with phi 2 is 2a naught. So it's a very obvious thing. It's a very obvious thing that any state can have n number of linear, n number of they can be represented in a n number of eigenstate. So you can get n number of eigenvalues. But when you will get which eigenvalue, nobody knows. This is the ultimate thing in the quantum mechanics. How we can understand all this thing? Suppose I can make another state, and another state, suppose the next state is, let's say psi 2 is all about 2 and 4. Or let's say something different thing. Psi 2 is, let's say, 2 and 9. Again, you will measure on state psi 2, you will get either a naught or 2a naught, because this psi 2 can be again written in a basis of phi 1 and phi 2. And you can easily write this psi 2, 2, 9 vector can be written as 2, 1, 0 plus 9, 0, 1. So again, this is the main thing about the measurement. This is just a representation. This is just a representation, but these two things is the main thing about measurement. Now your natural question is, suppose I will measure on the state psi 1, I will get a naught and 2a naught. And if I will measure psi 2, then again I will get a naught and 2a naught. Then what is the significance of these number 2 and 9? What is the significance of these number 3 and 5? Why we are taking this 3 and 5? We can directly say, okay, the answer will be a naught and 2a naught. What is difference between psi 1 and psi 2? This is the ultimate question, and this question will actually keep you always in a and will keep you always in anxiety. Anxiety means you will be always become a perplexing situation, that what is happening, how this can be happen. So this can be answered by the postulates 3. So let's try to go for the postulates 3. If you have any doubt, quickly you can raise the doubt, otherwise I will go for postulates 3. Okay, So I hope you understand the basics. So let's go for postulates 3. Once you will do this particular postulates 3, then everything can be answered very nicely. So we will that complete the first episode of understanding the quantum mechanics. That will be by the ending of postulates 3. So let's try to go for postulates 3. Now postulates 3 is will complete postulates 1 and 2, and they will combine postulates 1 and 2. So this will be postulates 3. And what is postulates 3? If A will, and this can be named as, I can just give you first the name, that will be named as probabilistic measurement of eigenvalue eigenvalue an on state psi. So this will tell you, now it's a very natural, you have more than one, there is possibility to more than one measurement. In a classical mechanics it cannot be happen, but in quantum mechanics there is possibility to measure more than one measurement for one physical quantity at the same time. So obviously it can never be happen that the two measurement will come together. Either this will come or this will come. Means if you are coining the if you are toss the coin, what you will get? You will get either head or either tail. You will never get head and tail together. So what should be the method to answer it is all about that the measurement can be either any of eigenvalue. So suppose any eigenvalue is an, and from the postulates 1 we know the state psi, and for the, if I know the an, I know the eigenstate. So this is a phi n is equal to an phi n. So I know this. What is meaning of that? If I am writing PAN, means probability of measurement of AN. On which state? Psi state. So PAN is probability to measurement on state is identified as phi n psi mod psi square. And yes, there is normalization part, psi and psi. This will give you the complete solution. Now, and this is nothing but the projection of psi in direction of phi n. This is nothing but the scalar product of psi in direction of phi n. That's it. And now you can find that all Pn, if you will go for summation over all Pn, that must be equal to 1. What is meaning of that? Meaning of that, you can either A1, you can measure either A1, you can measure either A2, you can measure either A3, but with some probability, with some chance. As we are tossing the coin, what we will get? We will get either head or tail. And yes, if it is fair coin, then what we will get? We will get 50% chance to get the head, and there is 50% chance to get the tail. Similarly, every measurement is associated with the probability. And if the probability is associated, then obviously average must be there. We will talk it later, but first let me give you one example so that you can understand the thing. So what we have any state psi, and let's say this state is 3 and 5, and let's say this is, I am telling it psi 1, and this is nothing but 3 and 5. And what is my operator? My operator A is identified as A naught 0 0 2 A naught. So where is postulates 1? Here is postulates 1. Postulates 1 is given. It is given. Postulates 2, you have to find the eigenvalue and eigenvector. So you have, what is eigenvalue? The A phi 1 is equal to A1 phi 1. A phi 2 is equal to A2 phi 2. And what is A1? I can identify A1 is equal to A naught, A2 is equal to 2A naught, and phi 1 is equal to 1 0, and phi 2 is equal to 0 1. You have to calculate. It is not trivial. You have to calculate this matrix and get the eigenvalue and the eigenvector. And now my question is that what will be chance if I am measuring the A on state psi? If I am measuring the state, the operator A or some physical measurement A on state psi, the measurement is okay, A naught and 2A naught. But what will be chance? What will be chance such that you will get A naught and 2A naught? Because either you will get A naught or you will get 2A naught. So the language is very strong. So you have to use either measurement is A naught or 2A naught. So this is the wonderful thing. So if you will tell me that, okay, either you are getting A naught or you are getting 2A naught, what is meaning of that? Suppose I am doing this experiment 100 times. How many times I will get A naught and how many times I will get 2A naught? Is there any other possibility? No, there is not any another possibility. Either you will get A naught or you will get 2A naught, but with the fair chance. And what will be chance? We can calculate from there. So let's try to calculate all this particular probability part. So up to this, if you have any doubt, you can just ask me. Then I will go for the calculation. Okay. So what we have, probability of measurement of A1 can be written as phi 1 psi mod psi square psi psi. This is the probability. And now this will be written as something phi 1 psi. So what is phi 1 is 1 0. You can write it from a bra, and this will be 3 5. We can take a mod square. What we can write 3 5 and 3 5. What you will get 9 upon 9 plus 25. So what will be the value? The value upon 9 upon 34. So this is 9 upon 34. Second, you have to tell me what will be probability to getting A2. So probability to getting A2 is equal to phi 2 psi mod psi square, and you can get psi and psi. And this we can be written as phi 2 is nothing but 0 1 and psi is nothing but 3 5. You can just take a mod square. This is very important. And this will be 3 5 and 3 5. Again, you will get something 25 upon 9 plus 25, that is equal to 25 upon 34. And if you are able to calculate probability of getting A1 and probability of getting A2, what is meaning of that? Meaning of that, you will get 9 upon 34 plus 25 upon 34 is equal to 1. And that is exactly outcome of due to completeness relation. Because you have so beautifully managed your vector, manage your state, in a basis of eigenstate, that total probability of getting the eigenvalue must be equal to 1. And now you can easily check. If it would be not 1, then there is some problem to choosing your eigenvectors. Means you are not choosing your eigenvector such that they can form a complete basis. But if you will choose the eigenvector such that they will make a complete basis, that means the measurement, the probability of getting the measurement, and if you will sum of it, then you will always get 1. This is the beautiful part. And now you can see the significant. If I will take, suppose here is psi 1, I have taken psi 1, psi 1, and now let's try to go for psi 2. We will try to understand what is going to happen. So I am not removing this part. I am writing the answer here for this thing such that we can compare it. So this will be 9 upon 35 and this will be 25 upon 35. Sorry, 34. 9 upon 34, 25 upon 34. So this will be the thing. Now let's go for psi 2 next. And let's say that psi 2 is again, you have what you can take. Let's say take 3 and 4. And again I am taking the same operator. The operator is again A naught 0 0 2 A naught. Again this operator is going to measure it. What will be measurement? The measurement is again A phi 1 is equal to A1 phi 1. A phi 2 is equal to A2 phi 2. And now you can say what is your A1? Your A1 is equal to A naught and phi 1 is equal to, again you have 1 0, A2 is equal to A naught and phi 2 is equal to 0 1. Now we can calculate the, I am using the same formula, probability of getting A1, but right now we are going for the psi 2. So if we are going for the psi 2, phi 1, psi 2, mod psi square, psi 2, psi 2. And what will be the answer? The answer will be, you can have 1 0 and this will be 3 and 4 and you will get 3 and 4 and 3 and 4. So what you will get? You will get 9 upon 25. And similarly, you will get probability of getting A2 is all about phi 2, psi 2, mod psi square. You have psi 2, psi 2. You will just check phi 2, 0, 1. And here is psi 2 is 3, 4. You can just take a mod square. And here you have 3, 4 and 3, 4. You will get 16 upon 25. And again you will add it, 9 upon 25 plus 16 upon 25 is all about 1. So now you can see the significance of state. Same operator. But if you are going to measure psi 1 out of 34 times, the probability to getting A1, and probability to getting A1 means probability of getting A naught. Probability of getting A naught is all about 9 upon 34. Means out of 34 times, 9 times you will get A naught and 25 times you will get 2 A naught. And if you will go for the another state, that will be 3, 4, then what will happen? Then you can find the probability is 9 upon 25 and 16 upon 25. So this is the thing. And once you know the probability, then you can easily find the average value. But the thing is that you will confuse. Okay, right now you are getting A naught or 2 A naught, A naught or 2 A naught. But when you are getting A naught, nobody knows. But when you are getting 2 A naught, nobody knows. Then how I can tell about the system? I am giving you another logic, and this logic is very interesting. Suppose I am taking exam of all of you, 100 people are in class. and then everybody get some marks between 0 to 100. And if someone will ask me, what will be performance of this whole class? Then what I have to do? I cannot say that performance of one of this class is the performance of individual students. No. What I can say, I can take an average value of that performance, because because your performance is all about distribution of the 100 people, and I need one number. I need one number such that I can give you the conclusion. Okay, what should be the actual number for the uh, all of class performance? Then what I will do, I will just measure the average value of your marks. Similarly, hence we are getting the probabilistic measurement, and the measurement is more than one. So what I have to do to define this psi, to particularly to analyze this psi, what I can do, I have to find the average value of operator A. On an average, what will be the number? On an average, this number may not be matched with A1 and A0 or 2A0, because it may be possible that average value of class will be 40 marks, but nobody get the 40 marks. And so why we are saying is expected value. So why we are saying is expectation value. So let's try to go for what is expectation value and how we will get the average value. So if you have any doubt, you can just ask me.
Sir,
Yes.
here we have A1 and A2. That is to A not equal A0. The A2 has the value 2 times of A1. But here the probability has no matching
There is
like that.
nothing to do. There is nothing to do. No, no, no. Nothing to do with this. You are. There's nothing to do with this. Nothing to do with
Okay.
this. Okay.
Okay.
The measurement is different
psi
thing.
value.
Yes.
The psi value has 3 and 4 or 3 or 5. Then how we think that A1 equal to A0 and A2 equal to 2A0?
Because from the postulates too, the eigenvalue is the measurement.
Okay.
In last class, I have told you. I have given you example. The postulates have tells you that the physical measurement quantity is the eigenvalue. That's it.
Okay.
And nothing to do with the probability to the number of eigenvalue. What is the eigenvalue? You cannot say that okay, it is 2A0, so probability should be double. Nothing to do with this. Nothing. You are saying the same thing, that the fat man have to get the more marks. Okay. So this is illogical. Okay. So there is not any correlation between probability and eigenvalue. No. Okay. There is not any correlation. Okay. So let's go for measure expectation value. How you can calculate the expectation value and how you will get and the expectation value is identified as average value.
Sir.
Yes.
सर पोस्टुलेट 3 स्टार्ट करते टाइम आपने स्टेटमेंट लिखवा रहे थे, वो बीच में रह गई थी, फिर इफ ए, उसके बाद आपने प्रोबेबिलिटी मेजरमेंट ऑफ आइगन वैल्यू स्टार्ट कर दिया था.
इफ
ए से कोई लाइन शुरू कर रहे थे, बट वो लिखी नहीं बाद में हमने इनिशियली.
यार अब मैं क्या बताऊं तुम्हें. Are you getting this postulates?
Yes, yes.
It's okay. Don't worry. I will give you a document. Don't worry about this writing. You are not in the history class.
सर ये कोई तो प्रोबेबिलिटी में प्रोबेबिलिस्टिक मेजरमेंट बोला ना सर, वो ये बोलना चाह रहा बस.
रहने दो, वो जो समझ रहा है उसे समझने दो, तुम उसको एक्सप्लेन मत करो. ठीक है. I will give you each and everything. Don't worry. In a writing, don't worry. I know this is very tough to comprehend, at least in online classes. I am also not satisfied with all this thing, but there is no other choice right now. Now, let's try to go for, so if I am saying this is nothing but known as expectation value. So what is expectation value? So if A will measured on any state psi, or you can find the expectation value directly. Expectation value A is written as psi, expectation value of A on state psi. Expectation value of A on state psi. So this will be psi A, psi, psi, psi. And this will be equivalent to, if psi can be represented in a functional form, then this will be minus infinity to plus infinity psi star, and let's say it is function of x, then I have to represent A also as a function of x, and we will get a psi x dx, and you will just go for minus infinity to plus infinity psi star x psi x dx. And if measurement can be continuous, measurement can be discrete. So for continuous measurement you can use this, but for the discrete measurement this can be easily written as summation over an, probability of getting an. So this is also identified expectation value of A. We will just solve the problem. When we will solve the problem, you will easily get this thing. So this can be, this is for the discrete basis or discrete measurement, and this is for the continuous measurement. Okay. Now this is the expectation value of A. Similarly, we can also find the expectation value of A square. So expectation value of A square can be written as psi A square psi psi psi. This can be written as minus infinity to plus infinity psi star x A square x psi x dx minus infinity to plus infinity psi star psi dx. And if you have using the discrete basis, then expectation value of A square can be written as an square, probability of getting an upon, and this will be the final value. So this is your average value and expectation value of A square. And similarly, if you are getting the average value, you can find the error into measurement, because there is chance, then there must be error. And this is something known as expectation value of A square minus expectation value A whole square.
सर इसमें इंटीग्रेशन वाले में डिवाइड में क्या विजिबल नहीं है
साई स्टार साई, जो ऊपर डिवाइड वही नीचे भी डिवाइड है, सेम थिंग.
ये नहीं सर नीचे वाले में.
अरे वही चीज है यहाँ भी डिवाइड भाई, बोल तो रहा हूँ.
ओके सर.
यहाँ तुम देख लो ना, ये क्या है, ये व्हाट इज दिस? लॉजिक लगाओ थोड़ा, आंख खोल करके काम करो. व्हाट इज दिस? व्हाट इज दिस? मैं उस लड़की से बात कर रहा हूं जिसने क्वेश्चन पूछा. व्हाट इज दिस? ये क्या है? Scalar product between psi and psi. And what is this? This is also minus infinity to plus infinity psi star psi dx. Okay, so this is nothing but error in measurement of A. Error in measurement of A. So we can calculate the error also. Obviously, it's a very simple thing. If you have any measurement and that measurement is not precise, then there must be some error associated to that measurement. And the whole distribution, then I can represent the whole distribution with a number, and that number I will just discuss later in a later part of our class, that number will actually tell you overall on an average what will be the distribution for the state. How you can represent for the state. The eigenvalues is for the eigenstate. But if you are talking about the state, the whole distribution, then you can use the average value. But when you are using the average value, there is margin of error. And that margin of error is measurement by delta A. So right now you can just keep this formula. When we will solve the problem, you have to use this formula. So right now I will just go for first discrete basis, and for continuous basis I will go for different in different class when it will come into picture. Now, so let's go for psi2. What will happen to psi2? And can we calculate the average value of A for psi2? So up to that, it's just a definition. So nothing to do with this definition. Okay. So let's go to calculate this to use this formula on state psi2. So what we have get? We have psi as, or psi2 as 3, 4. This is your psi2, and this is your psi2. And what will be measurement? Measurement is A1, and that will be A0, and probability of A1 is equal to 9 upon 25, and A2 is nothing but 2A0, and probability of 2A0 or A2, and you can write this, probability of A2 is equal to 16 upon 25. I am just giving you 30 seconds. Use this formula to calculate this thing. Use this one. Let's try to calculate how you can use this one. Just do this with yourself.
Sir, 41 by 25.
Are you getting this answer? So what you have done?
Yes, sir.
So you will use the, I will use both things. Okay. So you will use this formula. So probability, so what will be average value of A? The average value of A is summation over AN, probability of getting AN. And this can be, what is A? So this will be A1, probability of getting A1, plus A2, probability of getting A2. And what is A1? A1 is A0 into 9 upon 25, plus A2 is what? 2A0 into, you can calculate, that will be what? 16 upon 25. So you have 9A0 plus 32A0 by 25. And what will be that value? 41. 41A0 upon 25. So we have used this formula. Now you can use this formula also. You can use this formula also. So let's try to use this formula. So A is sandwich between cat and bra. So let's try to use this one. So what is psi? Psi is equal to 3, 5. What is A? A0, 0, 0, 2A0. And there is, again you will write 3, 5. And this psi is 3, 5.
3, 4, sir.
And 3, 5. Huh? sorry, 3 4 3 4, that is 3 4, that is 3 4. Okay, this is 3 4, so this will be 3 4. Okay, now let's try to calculate it. What will happen? So first you can go for this to this. I will keep 3 4 same. So this to this is what? This will be 3a naught and 8a naught, isn't it? By, you can just write it 25. 3 into 3 plus 4 into 4 is 25. Now how you can write it? You can write it 9a naught plus 32a naught by 25. Exactly same thing, isn't it? This into this 9a naught, this into this is 32a naught by 25 is equal to 41a naught by 25. And please look at this thing. The 41 a naught by 25 is not a measurement. It's not a measurement. What is measurement? Measurement is either a naught or 2a naught. But what is this? 41 a naught by 25 is all about expected value. If you will do this experiment again, and what will you expect? On an average, what will you get? On an average, you will get the value is 41 a naught by 25. So this is all about this thing. Now I am going to do the same problem in different way. Just I am going to ask the same problem in different way, and when we will use the kit and bra in our calculation. So let's try to go for the same problem in different way. Now, if I have operator A, and that will be phi 1 is equal to A naught phi 1, operator A phi 2 is equal to 2A naught phi 2. So what is this thing? What are this thing?
Eigenvalue equation.
Eigenvalues. These are eigenvalue, these are eigenstate. Eigenvalues, eigenstate. And suppose I just want to define the state psi. Suppose I want to define the state psi. What will be state psi? And let's say this state psi is 3 phi 1 plus 4 phi 2. My question is that if A will measure on state psi, what will measurement? If A will measure on state psi, what will measurement? Then what will measurement? Measurement is nothing with the eigenvalue. So measurement is A naught and 2A naught, because this is given, that eigenvalues are given. And now what will be probability of getting A naught? And it is also given that phi 1 or phi I, phi j is delta ij. Means they are basically orthonormal. So obviously what we will do, we will always represent our psi in an orthonormal basis of eigenstate. So probability of A naught is phi 1 psi mod psi square psi and psi. And now you can just use it. So you can take phi 1 psi. So this will be 3 phi 1 plus 4 phi 1 phi 2, and you will take the mod square, and here you have psi is all about 3 square phi 1 plus 4 square phi 2. All other term will be 0. And now which term is going to survive here? If you want to write, you can write this also initially. 3 into 4 phi 1 phi 2 plus 4 into 3 phi 2 phi 1. Now you can just ask which one is going to survive. What is phi 1 phi 1? That is 1. So this will be 3 mod square, sorry, I can write something like this. 3, 5, 1, 5, 2 is 0. This is mod square. And here is 3 square is 9. And 4 square is 16. You will get 9 by 25. Similarly, you can get probability of 2a0. I am writing it directly. That will be phi 2 psi. And you will take the mod psi square. This is psi and psi. What will be the value? The value will be, you can get mod 4 square upon 25. That is 16 upon 25. You can just check it. You will do the same thing. Right now, phi 2 will survive. All other term is going to 0. And the denominator, and in the denominator, these two term will be again going to 0. So what I have done? Which type of state I am talking about? The same state I have talking about, that if I represent the whole thing in a matrix form, I have to represent A as A0, 0, 0, A0. And what will be my psi? My psi is equal to 3, 5. So this will be the same thing. You have done it earlier in a matrix form. Right now we are doing same thing in a basically Dirac notation, or in basically in discrete basis. So if you have any doubt, you can just ask me. So in an examination, they can ask you in any form. So there is not any problem. Are you getting this?
Yes, sir.
If you have any doubt, you can just ask me. So don't worry, whenever it come to examination point of view, always try to see what is the eigenvalue, what is the state, and how you can write this state in a basis of eigenstate. This is the ultimate thing. But in a matrix form, it is not necessary that you have to represent in a basis of eigenstate. You can just you directly use the formula. And again, you can find the average value of A and average value of A square also. So let's try to go for, what will be the final time for class? 6:40. Okay. Okay. So the time is over. So this is the most important postulates. So I should give you one homework. Should I give you? Such that you can do it with yourself.
Yes, sir.
Just take a homework. Operator A is defined as 0, A0, A0, 0. So operator A is defined as 0, A0, A0, 0. If A will measure on a state psi, and let's say this psi is 3, 4i. This psi is 3, 4i. What will measurement? With what probability? What will measurement with what probability? So you have to, where is postulates 1? This is postulates 1. From here, you have to find the eigenvalue and eigenvector of the postulates 2. And here you have to find the, for this you have to go for postulates 2. And for this you have to go for postulates 3. Here postulates 1 is given. So just try to use it. And tomorrow we will finish the postulates part. And then one day we will just solve the each and every problem based on postulates. But tomorrow we will just go for the postulates 3 and the most important postulates, that is postulates 5, Schrodinger wave equation. Okay. So just try to do this with yourself. Okay. It will just clear all the concept.
So
Yes.
your eigenvalues will be A0 and minus A0, right?
Very good, very good, very good, very good, very good. And you can also find the average value. Yes, isn't it? You can find the average value of A also. You can also find the average square also. Don't worry. Just try to do all this thing. Yes.
सर ये सर डीजेनरेशन हो जाएगी यहाँ पे बस वजह से डीजेनरेशन पीरियड हो जाएगी यहाँ पे
हाँ, कहाँ पर होगा डिजेनरेसी?
प्लस माइनस की रेनोट आता है
तो डिजेनरेसी कहाँ है? ये तो नॉन डिजेनरेट है ना? ओके, चलो, थैंक यू.
Thank you, sir.